All right, let's get started then. So, hello to everyone. I know I can't technically see your faces, but thank you guys for joining me. I know that it's been a little bit difficult to not be in person, but as you guys are probably well aware, there is a lot of stuff going on, of course, in the science world and with COVID right now. We got a lot of projects going, working on Omicron-specific vaccines, working on HIV vaccines, the flu-COVID combination vaccines. So I really appreciate everybody working with me to be able to do this today virtually so that you guys don't miss out on anything. And hopefully in the future, I will see some of your faces again, either at future conventions or just around and about. But so let's get started, and welcome to Marten Microbiology. I guess to start, also, I believe I was told that there is some hashtag that you guys can submit if you have questions, and I will make sure that I have that up and running so that any questions that come in, I want to say it was Ask Chise, but don't quote me on that. Let's see. But while we're waiting for that, let's at least start with the panel and get this going. So a little bit about me. I am a senior scientist in vaccine research and development. I have had 10 plus years of experience in this field. Unfortunately, that's showing my age just a little bit, but that's okay. A lot of people ask me this question. Chise is a pine marten. She's not a stoat. She's not a weasel. She's not a ferret. She's a pine marten. And as for pronunciation, it is Chise. So let's dive into everything. I will say a lot of these slides that I have done have got a good amount of information on them, so don't fret. If you are interested in this presentation, you can just send me a message on Twitter or my email that I provide at the end, and you can ask for this presentation. I give you the link. It's a Google link, and it's easy to sit there and function through. But for the sake of today's presentation, and just to make sure that we don't run over, because I've run over at other presentations I've done, we will only be focusing on viruses today, but just so you know, there are many other areas of microbiology. It's extremely expansive, dives into bacteria, fungi being molds and yeast, protozoa or protists, and then viruses, of course. But what is important to pay attention to, especially when we're talking about viruses and viral diseases today, we are talking about differences of prokaryotes and eukaryotes. We as humans are eukaryotes. We're complex, multicellular organisms. We have a nucleus, contains a nuclear envelope, and then we also have, of course, with our cells, we have cell membrane-bound structures, mitochondria, etc. Whereas prokaryotes, like bacteria, they're kind of simple. They're usually, and when I say simple, I don't mean like, they're not, special or anything. They're just simple in the fact that they're not as complex as we are as a system. They're usually single-celled organisms, contain a nucleus and no membrane-bound structures. So if you look here, you can see, the little star, like when you're lost at the mall when you were a kid and it says you are here. This is where we are. So, the only thing with this presentation, I think because of how I'm sharing my screen virtually, it might not be able to go fully over to videos. But again, I'll give this link to you guys. There's nothing in these videos that I can't explain to you when we're talking. But for those of you I'm going to ask, and I know I probably can't hear you guys answer at the moment, but do you know if a virus is technically a prokaryote or a eukaryote? And in the end, kind of a trick question because viruses are technically neither. They're neither prokaryotic or eukaryotic. They're not made up of cells. Viruses cannot replicate in their own. And most scientists, I'm not going to say all, but most of us consider viruses to not be living. Some people will, in the past have created some arguments and, hypotheses as to why we should consider them living. But when I explain to you exactly what makes them the way they are, you can see that organisms like us, viruses don't necessarily fit into that structure. So, well, I'm not even going to say the last time that you had a sore throat or a fever. Now with Omicron, and again, like I said, this presentation has kind of changed and things have changed since this. There think about maybe the last time that you've had a sore throat or a fever or a cough, kind of things that you might experience if you have had COVID before. And with Omicron, a lot of things that people are experiencing, because you're going to find that it infects more of your upper respiratory system, your nasal passages, your throat. You might even have an earache. Um, think about the last time that you had dealt with that, or if you've had flu in the past, or just any maybe little cold that you might have had during the winter season. Um, good chance is that you were fighting a virus, obviously. Viruses that cause colds, such as, dealing with RSV, or you might have had an adenovirus, you might have had a rhinovirus. Those kinds of things are going to affect you and have you feel symptoms like these. But viruses don't only affect humans. They can affect animals, plants, and even bacteria. Um, and literally, viruses or bacteria that make other living things sick, like us, our pets, family and friends, they're called pathogens. So one thing that a lot of people don't realize is that while viruses and pathogens, you might hear the word and you're like, oh my gosh, it means a bad thing. Technically, they're not all bad. There's bacteria that are helpful, that live in oceans and soil, that are important to cycle nutrients. You guys know that there are bacteria that turn milk into yogurt, or cheese for us to eat. You also have healthy bacteria in your gut, and without those, your system wouldn't function the best without them. So these guys that are helpful are called mutualists. So again, for example, if you are sick, or you might have a condition that might strip you of your gut bacteria, that's something that's, helpful, that you want to keep around. So don't think that all viruses and bacteria are bad. But there's good ones and there's bad ones. And something that's really interesting when you think about the size of a virus, and I believe I have this on the next slide, think about how small the period might be at the end of one of my sentences here on your screen. That's about the size of a virus, in the sense that, maybe if you could possibly see them, it would be even smaller than that. So they're very difficult to see. You can't really see them with the human eye. So catching viruses. There are many ways that you can catch a virus. Think of mosquitoes with malaria, or West Nile virus. The ones that you can get that cause colds come from infected individuals when they sneeze or they cough. Once out, when you inhale them, or you might touch a surface that they're stuck to, that's how you can contract a viral infection. Now, when it comes to COVID, of course, when it travels through droplets in the air, I remember when we first were talking about COVID, or SARS-CoV-2, I should say, because technically COVID-19 is the disease that it causes, but SARS-CoV-2 is the actual virus itself. So when we talk about infection, we talk about, it being through SARS-CoV-2 virus. You talk about disease, you're talking about COVID-19. So they are different, and it's important that we don't conflate infection and illness. So plenty of ways, and this is really helpful, especially for you guys who are at the convention right now, to protect yourselves and others around you. For one thing, stay home if you feel sick. If you're feeling under the weather, if you have a sore throat, if you've got a fever, if you're sneezing, if you're coughing, stay home. I know it's a little bit harder, especially when we want to be like out and about and doing things again. And it's just easier to be able to control the spread of things. And this isn't just in relevance to COVID-19. It's in relevance to flu. It's in relevance to anything that you might be experiencing. Even if it is just a cold, if you don't feel well, stay home. If you are sneezing, obviously, cover your snoot. Don't sneeze into your hands, please. And if you're sneezing into a tissue, throw the tissue away immediately and go wash your hands, because that's going to still get all over you. But don't sneeze into your hands and then go touching something or touching someone else. That's how it can spread as well. Another big thing, wash your paws. Soap is a great tool against viruses, because it can help break open the fatty envelope that surrounds them, and it can help destroy them. It won't destroy all viruses, but in the cases that when you're washing your hands, and in some viruses, when it removes the dirt and oil from your skin that they stick to, you can rinse them off. So I think what was that when we were taught when we were kids, like singing "Happy Birthday" or like "Twinkle Twinkle Little Star" when you're washing your hands. Just make sure that you're washing them thoroughly enough and long enough that you're getting that off. I'm not saying that you have to wash, profusely and rip your skin off. Not like that. Just do it gently and get them off. And so again, like I said at the bottom, cover your nose when you're sneezing, and just abide by these rules when you are out and about. So, what does a virus look like? This is actually one of my favorite slides because not everybody gets to see these. So, when you're looking at viruses under an electron microscope, you will see these images on the right. Whereas when we're looking at maybe a biology textbook sometimes, or just, on a general website that contains some information, you might be more familiar with the pictures in the middle, which is, like your general diagrams for a virus. And the other thing is that some people don't realize viruses can contain DNA or RNA. So they're a little different. They might be either or. But when we talk about how big they are, so if you could magnify a cell until it was about the size of a basketball, a virus would only be about the size of a single period on this page. That's how tiny they are. These guys are like, well, these viruses that aren't really that great are kind of ruthless. Very, very tiny, but very powerful behind it. So parts of a virus, the simplest virus only have two parts. Genome, like I said, it's either DNA or RNA, and that is a blueprint with instructions for making more viruses. So think about them like almost like building blocks. And a capsid protein shell that protects the genome. Viruses also often have proteins called receptors that stick out of their shell and help the virus sneak inside a cell. So a lot of the viruses that infect us and maybe our pets and some animals in the wild also have an envelope creating like a cell membrane. So while a virus doesn't have an actual cell membrane, it's got an envelope. And this envelope is what protects it, and it's very hard to break through sometimes. And that's what makes these guys so difficult to deal with. But so with these just being the basics, more complex on here, what you might see. So above right here is swine flu. We're going from the top left over to the right and then down again. Swine flu, vesicular stomatitis, avian influenza, this little guy, SARS-CoV. One of my favorites that I like to look at just because it's a really interesting. Normally when you talk about viruses and when you think of a virus, most people think about a bacteriophage. It almost looks like a spider that kind of like latches out and hooks onto something. So normally you'll see these. We have Ebola. We've got polio, which has a very interesting shape to it and is very uniform. And then over here we have, lastly, Marburg virus, which is one thing you definitely don't want to deal with. So how do viruses work? I'm gonna see if this video works. I might have to get out of the presentation to be able to share this screen, or you guys might be able to see everything. If you can't see this, then let me know, or if you can't hear it, but it should share it. And I'm really sorry, the music is a little bit on the dramatic side. I'm not sure why they go with this sometimes, but just know that the message behind it is what matters.
We don't have any audio.
Oh, you guys don't? Okay, darn. Wonder. Okay, let me explain it like this then. If you guys don't have any audio and it's just playing the video, then I'll explain what's happening here. But literally what you're seeing right here is a virus circulating, and these are your cell receptors. And what you see on there is what the virus has to be able to, well, it gives a little bit of detail on here, what you're looking at. I think I can put closed caption on. Okay, let's see. And if it doesn't work, like I said, we'll explain. Can you guys see the subtitles at least?
This is the moment when infection.
So right here is contact, and it's showing that this is what, okay,
The,
perfect.
our screen size is so small, we can't read the subtitles, so you'll have to explain it.
Okay.
Yeah.
Okay, that's no problem. So what's happening right here is that you see viral surface proteins on the virus, and it literally links onto your receptors. It's almost like a lock and key fit. And when you're dealing with SARS-CoV-2, this is what happens. You have receptors on the cells of your on your lung cells, and what will happen is when that virus comes in contact, it links with those receptors and it will use those receptors to pretty much initiate its, how do I put it? I'm going to say not even unloading of its material. Sorry if you hear a bark in the background, that's my dog. What happens is viruses cannot reproduce on their own. They literally need your cells to be able to replicate. So what does the virus do? It comes in, it links to the receptors on your cells, and then it sits there and it unloads all of its content into your cells. I know it sounds a little creepy in a sense, but that's really how they work. This is the virus infection cycle. And once they've put that their genetic material into your cells, they instruct your cells to replicate that material. So if you can see here in number 4 on this slide, this is what happens. They come off and they bud off and they kill that cell, and then they start sitting there and spreading. So when we go into the rest of this presentation, I'll show you exactly how immunity and vaccines help this from happening and stops the virus in its tracks. So for the next couple of slides, I go into some viral diseases. Some of these you guys might have heard about. Some of them you may not have heard about. One thing to know is that viral diseases are not always contagious, meaning they can't spread from person to person, but a good majority of them are. Common examples being flu, common cold, HIV, herpes, SARS-CoV-2, obviously, especially Omicron being fairly transmissible. These guys are pretty contagious. Measles is another one, but first starting with respiratory viral diseases, most of these are going to affect your upper or lower parts of your respiratory tract, and they're going to produce symptoms like runny or stuffy nose, coughing and sneezing, fevers, body aches. You guys know how that feels, I'm sure. I can't see how many people in here, if you've had to raise your hand and say you've had flu before, you would probably have experienced things like this. Transmission normally through droplets generated through coughing or sneezing. That's why I said, before, when you are sick, if you're sneezing or coughing, cough or sneeze into your arm, to make sure that you don't spread it anywhere, and then make sure to wash your hands immediately after, because they can spread through, touching an object like doorknobs, tabletops, anything. And then treatment, a lot of things like flu, and even colds, because there's really not a cure for a cold per se. You can get over-the-counter medications like nasal decongestants, cough suppressants, pain relievers, those kind of things. But for influenza, flu is always an interesting thing because it mutates at such a astonishing rate that we're developing vaccines each year just to match the new influenza strain we're dealing with. But Tamiflu, an antiviral drug, sometimes prescribed to someone. When I've had a really bad case of the flu before, even like norovirus, they will prescribe Tamiflu, and you got to make sure that you take like the whole entire pack, relatively, within the first couple of days of experiencing symptoms to help knock it out. Oh, and then of course, lastly, there obviously is, like I said, again, the vaccine that you can get yearly for flu. Another viral disease, looking at gastrointestinal viral diseases, excuse me. A lot of these, you might experience abdominal cramps, vomiting, just gastric upset in general. Norovirus, like I mentioned, if you ever had like a really bad season of flu or a norovirus has knocked me on my butt before. I think that was back in, I want to say that was it might have been 2010, 2011. I mean, just like 3 or 4 days where you're like stuck on the sofa and you don't feel like eating anything and you've got a fever, like those ones can really knock you back. Transmission, these guys transmit in their own way. You're not really going to find that maybe you're transmitting through sneezing or coughing for these, but, still best to isolate yourself, take care of yourself, and definitely when you have such a thing to make sure that you drink plenty of fluids because these guys can really dehydrate you rather quickly. So it's always best to, get some Gatorade or some Pedialyte, and ginger ale in cases too, to just make sure that you stay. Ginger ale is a little bit drying out, so I would say more so Pedialyte or Gatorade because it's got electrolytes to help restore. But definitely something that you want to pay attention to when you have something like this. Obviously, washing your hands, washing your hands, washing your hands is always a key for prevention for things like this. I know with COVID-19 circulating around, we almost sometimes forget the basics of how to stop things like this in its tracks. When it really comes down to it, it's very simple. Like, always start with your basics. Always wash your hands. Let's see. I think, okay, so these ones are, I'm not even going to say they're a little bit more rare, but you really don't hear about them as much as we might have before. And I'll tell you why, because of vaccines. Back when maybe we were younger, or maybe even our parents were younger, you've heard of things like measles, rubella, chickenpox, or shingles. I unfortunately, and again, I'm going to be showing my age in a minute, I was not one of the lucky ones that had access to the chickenpox vaccine because that came out after the fact that my cousins and I got it. We all used to live together when we were kids, and all three of us got it at the exact same time. However, when my brother and my other cousin were born, they were lucky that the chickenpox vaccine was developed and out for them, so they didn't go through it at all. But some of us might know and remember exactly how bad chickenpox was. It was very irritating. The, you know, trying your hardest not to scratch, and then the oatmeal baths and everything of that sort. So it's great that we've got vaccines for these things. Also smallpox. Chikungunya is one that you will probably not hear much about in the States, but you will in other countries. So when you think about these viral diseases, these are some popular examples that you'll find. Again, with transmission, these are through respiratory droplets, coughs or sneezes. Chickenpox and smallpox, maybe not so much smallpox, but chickenpox at the time being transmitted by coming into contact with broken skin lesions. This is why they would tell us don't scratch, don't scratch. And then chikungunya is through mosquito bites, but cannot be transmitted from person to person. So treating these, fever-reducing medications, acetaminophen, you can get some antiviral drugs. But again, before the vaccines came out, we didn't really have much to be able to help with these things. But to be able to just kind of like, smooth on some lotion and tell yourself just don't scratch. Viral diseases. Also, I don't know how many of you guys have seen this, but Osmosis Jones, really good film, but there are some things that are like fact, and then there's some things that are just like total fiction with this movie, which I would love to break down one day in a panel just for fun. But looking at hepatic viral diseases, these guys cause inflammation of the liver. A lot of people are familiar with hepatitis. Cytomegalovirus or yellow fever virus, these guys can all affect your liver. Transmission, they can be transmitted through bodily fluids, so coming into contact with blood, needles, razors, or it can also, hepatitis B can be spread through sexual contact. So just things that you want to be careful, obviously, to not share with people when it comes to those. We have treatments for hepatitis B and C and D. This focus on managing your symptoms. Your doctor might prescribe medication like antiviral drugs. And then one thing that was interesting that I found, you can only develop hepatitis D if you've already had hepatitis B, but that's the only case for that. So again, like I told you with prevention down here, these are some things that you can do to help avoid these. Cutaneous viral diseases, these guys are really interesting because it's like you're not going to see that anything is like super severe, but it's something that you don't want to have, obviously, like warts or herpes, those kind of things that you might have. They are contagious. They can spread through physical close contact. So if someone has like, a mouth sore or that kind of thing, or if you have like warts, things that you want to like, get treatment for so that you don't risk spreading those to someone else. Um, oh, these guys. So remember when I told you guys Marburg was something that was pretty devastating? Think about when Ebola first came into the news. Now, if you guys can imagine, COVID right now is obviously a very big thing that we are dealing with. And while we now have vaccines, which make things a little bit easier, it's obviously there's no denying that COVID has also, taken quite a toll on our country and the world in general. And then while I'm here, I'm going to sit there and I'm going to thank AnthroExpo for, of course, your, wonderful COVID-19 policies and protocols that, the team has put in place to help keep you guys safe. I know that they have been doing all that they can to help while we're dealing with the spread of Omicron at the moment. So thank you, AnthroExpo, for, of course, doing that and taking everybody's health and safety into account. So with that said, can you guys imagine if COVID, the way that it circulates right now, would be at the state of maybe what Ebola was like? And if you guys remember, Ebola didn't really hit the US, but it hit places like, Africa and countries within Africa where it was just devastating. So if you can imagine that kind of level where you have high fever, you've got body aches, bleeding under the skin, bleeding from mouth or ears, or bleeding in internal organs, and just general weakness, it would be something that's really not very fun to deal with. And other examples like this, not only Ebola, but dengue, yellow fever, Marburg virus. So these are some things that we might not be facing here in the US, but that other countries deal with or have dealt with, that can be really detrimental. And the issue is that there's really no specific treatment for these viral diseases. But again, staying hydrated and restoring electrolytes that are lost with things like this is most important to help patients or those who are infected, to at least have a little bit of an ability to be able to help fight this. But when it comes to prevention, we're always, trying to stay ahead of the game where we're working on vaccines to help prevent things, because while cures are fantastic, prevention is always your first key. It's better to help prevent something as much as you can, and then, use treatment afterwards. So now with COVID, we have vaccines, of course, as your preventatives. And then you have antivirals, monoclonal antibodies, things that can be used after, to be able to help somebody who maybe is facing COVID and is having a rough time with it. So we've got, several other things in our arsenal that we can use when it comes to these viruses. So neurologic viral diseases, such as like polio, viral meningitis, encephalitis, and rabies, being a big one, especially with wildlife out there. I didn't have meningitis, but I had a fun story to tell, like with people when when I'm giving this presentation, that, in my undergraduate career in college, I had a roommate and we weren't always on the best of terms with each other because you're not always going to get along with roommates. But I fell asleep one night at my desk studying for finals, and I unfortunately slept in a very bad position, and my neck was craned the wrong way in my book. So when I woke up the next morning, I proceeded to not be able to move my neck, and I was very stiff. And for whatever reason, my roommate took it upon herself to go run to our RA and say, hey, I think she might have meningitis. And of course, when you're on college campuses, they take meningitis very seriously. Um, And of course, that resulted in going to the hospital, even though I, tried to profusely, justify the fact that I fell asleep. I wasn't sick. I was just tired. But of course, studying for finals brings your immune system down and you're stressed out as is, and you don't really look the best. So I had to go to the hospital and they gave me a spinal tap. And I am not a very, it's really funny as a vaccine researcher telling you guys this, but saying I'm not a fan of needles. I am really not a fan of needles. I can administer them, but I cannot take them myself. I hate it. It just I get like such a flush. Um, but yeah, that has probably been the biggest needle I've ever seen in my life. So they literally will go in and they will. It's as it sounds. They tap your spine, they get some spinal fluid, and then they see if you have meningitis that way. So that's how that works. Um, but yeah, certain things like this, especially with polio, if polio was really bad during the time when it was out, and of course with the vaccines that came out and that entire drive to vaccinate, of course, was something that people maybe older than us or even our parents experienced. And now, again, with that vaccine out, being able to not say, "Hey, we don't have to worry about polio these days," it's not exactly something like that's widely circulating. Obviously, like COVID. And I believe with polio, in certain countries, it's not exactly considered eradicated, but, in the US, we consider it kind of like on those terms. But for transmission for these guys, a lot of these can spread through the bite of an animal or a bug. Obviously, rabies, through infected animals. Lyme disease, I think, would be another one of these that would be obviously it's transmitted through a tick. Other viruses like polio and other enteroviruses, those were spread through close contact with someone else. Also, contaminated objects or vectors can contribute to the spread of these. So there's no specific treatment for meningitis or encephalitis besides getting rest, staying hydrated, over-the-counter anti-inflammatories. And then, of course, with polio or meningitis or encephalitis, additional treatment like breathing assistance or IV fluids. If you have ever been bitten by a wild animal that was suspected to have rabies, you will be given a series of shots to help rabies from infecting you. I know I've heard that one has been pretty intense. I, knock on wood, have not had to deal with that. But this is why it's really important, watch wildlife from afar, not close up. So of course we know there's a vaccine for poliovirus and mumps. Mumps, measles, and rubella is a 3-in-1 pack of a vaccine. That one really smarts because they'll give it to you not in your muscle, so it's not IM. It's actually like subcutaneous, right under in the fleshy part of your underarm. That one really smart. I had to get that twice because they couldn't read my old pediatrician's handwriting on my immunization record. So I had to get that before I got into, years ago when I started working on viruses and stuff. I had to get that again. But prevention in general, practicing good hygiene all the time will sit there and help you with these. Reducing the risk of spreading rabies. So if you have pets, make sure that you keep your pets vaccinated. And again, avoid approaching wild animals. So the bottom line for all of these, there are many viral diseases, common cold, stomach flu, all of these that can, be minor and go away, on their own in a few days. But some definitely are more serious. But unlike bacterial infections, we know viral diseases don't respond to antibiotics. Why? Because antibiotics are for bacterial infections. Antivirals are for viral diseases. So, of course, treatment usually focuses on managing symptoms and supporting your immune system with plenty of rest and hydration, and most of all, vaccination. So let's get into the nitty-gritty about your immune system. I won't go through all of these just for the sake of time. I'm making sure to watch ourselves. I don't know what time we started, but I know we started a little bit after 1 p.m. your guys' time. I'm on EST right now. But epithelial cells, what is your largest organ? it is technically your skin. This is your first barrier for protection against viruses. This is why it's important to, if you have a wound, or you have, if you've had surgery, let's say that you fall and you get a cut. Best thing to do is to clean it up and make sure that you bandage it, disinfect it, because guess what? If you don't, you have an opening for something to get in. If anybody remembers when staph was going around, I unfortunately was one of the unlucky ones that got a staph infection. And if you don't know what staph is, it's an actual bacteria. Now, we all have Staphylococcus aureus on our skin naturally. It's there. It's like one of those bacteria that's just kind of around. And I don't mean to freak anybody out. It's just there. However, in large amounts can cause an issue for you. So when it was circulating and staph was going around, I unfortunately, and this is when I was way younger, I unfortunately had a thing for, if you got a breakout, and, your parents or your friends or whoever, your doctor might tell you, hey, don't pick your skin. Don't pick your skin. Don't try to pop a pimple. Don't do that. Why? Because as soon as you do that, you open yourself up to an infection, in the sense that you have pretty much broken open your skin barrier and left it open. So unfortunately, I must have got this from a doorknob or whatever I had touched. It was during the time where it was like, general physical education in college. And, gyms and locker rooms, maybe not always the most disinfected. So unfortunately, I was picking at my skin and trying to, mask up the latest breakout that I might have had at the time. And unfortunately, I contracted a staph infection. And you know that you have a staph infection because it's kind of like almost like flesh-eating bacteria, where it breaks open your skin and it makes it almost look like you rubbed like brown sugar onto your face. It's very weird. And that's where like Staphylococcus aureus gets its name. It's gold. It looks gold. So it looked like brown sugar scrub on my face, but it really wasn't that fun. It almost felt like it was very sore and very tender to the touch, and it almost just kind of stung. So again, taking care of your skin is one of the first things that you can do to make sure that, viruses don't break in through that barrier. Now, you have several layers of it, obviously, being squamous, cuboidal, and columnar. So you've got several layers of your skin, but it's just, like I said, if you have a wound or an injury or anything, this is why it's important to take care of that and disinfect. And then again, keep your hands clean, keep your skin clean. Hygiene is super important when it comes to fighting against pathogens. Macrophages. So we're getting into the nitty-gritty about the guys on the inside. So macrophages are early to this scene. They're a white blood cell. They're one of the first types of cells at the site of infection. So let's say that you got cut, or you fell off a bike and you scraped your knee. Infected or damaged cells, like your epithelial cells that we just talked about, release chemicals that attract macrophages in nearby blood vessels. And these guys will come in. They really can squeeze in through some really small spaces. And they will come in and start pretty much getting to work. I guess another example I had here, if you've ever had a splinter that felt hot and swollen, like a day or two after, the cells at the splinter pretty much are sending a signal. And when your blood vessels let macrophages in, that some of the blood will seep through into that area. And that extra fluid and those chemicals released by your infected cells can cause that inflammation. So while it hurts, inflammation actually is not a bad thing when it's starting to initiate the process of healing. So just something to keep in mind. Macrophages and neutrophils both work to keep your body clean of debris and invaders, and they'll also call for backup when an infection is too big for them to handle by themselves. And that's where T cells and B cells will come on in, and we'll talk about those. One interesting thing about macrophages, their name actually means big eater in Greek. They're the biggest type of white blood cell. They don't eat in the way that you think that they might eat your food. We should be able to see this, and there's no audio or anything on here, so don't worry, you're not like missing anything. But literally right here, this is a macrophage, and this green that you see, that was a little bit quick, so I'm going to put it back for a minute, and I'll explain. This is a macrophage right here, this little gray thing that you see, this really big cell. Sorry about that. The white right here is an infected HIV infected T cell. And that green fluorescent that we see is what we helped, you can put in that marker to help you see infected cells. So what you're going to see right here, this macrophage literally almost like just, if you can imagine, he has like a little straw, he literally sucks that thing up and they engulf infected cells. So that's kind of how these guys work. Where's my presentation? There we go. So that's what they do. They're not like sitting there and chewing it. They literally engulf viruses and bacteria. And that's phagocytosis. That's the word for that. All right, and then neutrophils. Neutrophils are early to the scene as well. We talked about them in the last slide a little bit, helping along with macrophages. But these guys can fight off invaders in a number of ways. They can eat them, they can fire antimicrobial proteins at them, or they can set up what we call like little web traps outside of cells, and they can catch and kill in like any invaders that they might see. It's really interesting how our immune system works. It's completely complex and quite a very, I'm not going to say magical, but just astounding system in itself. So definitely make sure that you give your immune system credit, because it's quite amazing, and it's working every day to protect you and others around you. But literally, to keep it short, neutrophils both help and hurt during a fight against microbes, and in the way that it's a balancing act. They have short lives in the sense that they can help keep things under control. But as long as the fight against invaders continues, neutrophils are called to replace cells that die. But the thing is that after the infection is under control, no more cells should be called, obviously, and the remaining neutrophils will start to die. In most cases, they'll be swallowed up by macrophages. And like I said, the macrophages are always there to help keep the infection, the area of infection, to be clean. So macrophages are just literally like, almost like a, I'm not going to say garbage disposal, but in a sense they are, because they're there to clean up everything afterwards. Yes, I know there's a lot on this slide. We won't be able to go into all of it, but again, if you want this presentation, I will definitely be able to give it to you guys. T cells. T cells are something that don't get a lot of credit, because normally when we think of infections or we think about vaccines, the quickest thing that we think about are B cells. Because B cells are literally like one of your first lines of defense. But T cells really help, because you've got helper T cells and you got killer T cells. And their name is exactly kind of like what they sound like. Killer T cells do the work of destroying infected cells, and helper T cells coordinate the attack. Now, before anybody kind of like panics, yes, killer T cells do destroy infected cells, and people think that they don't get replaced, or that, that means something bad, but when infections occur, your T cells will help out. They're there to help you. So if you ever see anybody saying, oh, like T cells are bad and you got cytotoxic T cells and you got killer T cells and this and that, yes, they're there for a reason. They know what they're doing. This is how your system has worked for, as long as humans have been around fighting infections. So killer T cells will find and destroy infected cells that have been turned into virus-making factories. This is, a lot of research has shown that T cells obviously will help us with severe disease. So for example, like, with COVID, this is a great example, SARS-CoV-2 infection. If you've gotten infected with COVID and you've had maybe a cough or a fever, or you've been on bed rest for maybe like 2 or 3 days, and then your infection, cleared, your T cells have been helping you to not face severe disease and worse. So something like hospitalization or death or anything of that sort. So that's why I say, a lot of credit goes to your B cells, but a lot of credit needs to go to your T cells too. Because if your B cells, let's say that, for example, with Omicron, neutralizing antibodies, Omicron can evade, antibodies to a much larger extent than maybe previous variants. You might face an infection, but you're not facing severe illness. So the great thing is that, your T cells, whether it is through previous infection or vaccination or a combination of the two, you've got some that will, help you to not have to face the worst of all of this. So just some things to keep in mind. This is for T-cell screening. You guys can read this on your own if you'd like, but this is literally where T-cells come from and what they do. So a little bit more in depth. So B cells. Interesting thing about B cells, you think that they probably got their name because they're made inside your bones. While it's true that most blood cells are made inside the bone marrow, that's not where the B comes from. It actually comes from bursa. And bursa is an organ found in birds. It's really interesting, the whole story behind these. And unlike T cells and macrophages, B cells don't kill viruses themselves. B cells sweeps up over the leftover viruses after a T cell attack. B cells are as important as T cells. Like I said, they both play a huge important part, but don't just think that B cells are like the only part of your immune response, or antibodies are the only part of your immune response, because they're not. But again, they have their own thing that they have their own job. So in other words, B cells attack invaders outside of the cells. And then let's say that your B cell defenses, might not be as strong and an infection gets in. Those T cells come and they will, attack the infected cells. So they both work off of each other and help each other. But when you hear B cells, you'll hear that a lot of people will talk about antibodies as well. So antibodies being, like I said, your first line of defense when you're dealing with an infection. And what happens is these antibodies will trap invading viruses or bacteria. And you can see here what we're looking at when they're binding to antigens. Antibodies will bind to the receptors and they'll stop a virus. Let me put it like this. When a virus comes in and is trying to invade your cell, remember when we were seeing in that video, you see all the little, they almost look like little legs or whatever, or receptors coming out of the virus. Your antibodies will come and they will attack that virus and they'll hit that thing from all sides and link with the receptors on the virus. So what happens is when that virus collides with your cells and tries to hit your receptors on the surface of your cells, it won't be able to. And the reason is because those antibodies have now binded to that cell. They can no longer they've binded to that virus. The virus can no longer bind to your cells. That antibody is blocking it from doing so. It literally has created a block on the receptors of the virus to not be able to link and hit their receptors on your cell. So just think of it as just a block that came along. Memory cells. Memory cells are something that are fantastic because let me think of it like this. When you were in school and you studied for a test and you studied and you studied and you studied, and then you come and you take the test the next day and you're like, oh my gosh, I remember everything, or hopefully you remember everything. I can't say that I ever have either. But you hope to retain all the information that you studied the night before. Memory cells never ever forget a pathogen that they have come into contact with. And that's what's so great about our immune system. So, for example, you got vaccinated against, let's say, measles, mumps, and rubella. You've trained your immune system as to how to recognize a virus because that's what a vaccine is, right? You're not infecting yourself with the virus. You're not going through, that route of facing an infection. You gave yourself a vaccine and you've trained your system how to memorize this. So what happens is it might have been years since you've had your measles, mumps, and rubella vaccine. But if you were ever exposed and came into contact with it, your immune system remembers and retains that information as to how to fight that virus. And that's what's so great. So the thing is, too, if you do get an infection, and let's just say that, it's not just from a vaccine that you're training, that you receive this training from. Let's say that you're vaccinated and you do face an infection. For example, let's take Omicron, for example, because this is a really good one since it's obviously relating to, current events. You got vaccinated, you got boosted. Let's say that you got an infection with Omicron because it's just that transmissible. And let's say you had a mild infection, you got some coughs, you got, a little bit of stuffy nose, you had a fever, you might have had a sore throat. You got over it, it's been a couple of days. What happens is your immune system now recognizes that virus inside and out, not only by its spike proteins, but by its nucleocapsid proteins. It's memorized that virus, on all sides of it. So what happens is if you're ever exposed again, your immune system doesn't forget that it came into contact with that virus before. And now, not only does it know how to fight the virus, it knows how to fight it even better this time around. So as where before, and this is what this graph up here is shown, your first time the virus has attacked your body, this is the second time your virus, the same virus has attacked your body. But guess what? Your system knows exactly what to do now. Your antibodies are going to shoot up because they can make them even faster this time. And this is what I explained before. So at day 0, someone catches a virus. At day 10, her B cells start making antibodies, and by day 15, she's made enough antibodies to destroy all the virus. Now she doesn't make any more antibodies, so fewer and fewer are left in her body. At day 40, the same virus gets in her body again. She has memory B cells prepared to fight, and she can quickly make 100 times more antibodies than she did during the first infection. So that's where your memory cells come in. So don't ever sell these guys too short, because they know exactly what to do if they ever come in contact with it again, and they know how to fight and protect you even better this time around. So vaccine science. This is going into some history of vaccines, and of course I had to put Balto in there because that's one, of course, a lot of us know and are familiar with. With tetanus, for example, let's say, I would hope that most people remember to get their tetanus vaccine. Oh, yeah. Oh, absolutely. Absolutely. Because I know we only have a couple more slides left. So I won't go into all of the brief history here, but you guys can read all about this and where vaccines came from. Wrapping up for herd immunity and why. So some people who can't be vaccinated, let's start with that. Some people out there who they might be allergic, or they might be immunocompromised. They might not be able to get vaccinated. Why it comes into play, why it's important for all of us to be able to get vaccinated, is considering herd immunity. Now, some people say, well, the vaccines don't prevent all transmission, so how can we acquire herd immunity? The thing is that while vaccines don't prevent all transmission, they still prevent some. So it's better to have more people vaccinated in the end than not, to be able to help people who cannot get vaccinated. And then one really important thing from this slide, I hear this line all the time, but wait, I still got infected. Does that mean the vaccines don't work? That could not be further from the truth. So let's talk about sterilizing immunity versus protective immunity and breakthrough infections. Literally, you have something called protective immunity, and you have sterilizing immunity. Sterilizing meaning that, once everybody gets vaccinated, you can't get infected ever again. Some people think that polio was a sterilizing vaccine. Not necessarily. It took a lot of people getting, vaccinated, and the thing is, it still didn't prevent 100% of infections. But because the majority of people got vaccinated, that's why we don't have to really deal with the nasty effects of polio anymore. When it comes to protective immunity, think about influenza. You can get vaccinated for influenza on any given year, and you can still end up getting the flu that season. Does it mean your vaccine didn't work? No. It meant that your vaccine was sitting there and helping protect you from severe disease that might have been caused by influenza, but you still maybe had a little bit of a slight infection with it. And while it's not fun, again, it's still protecting you from the worst. You guys probably know a lot of this from following me, but vaccines, stimulate your immune system. They program your body to be able to fight things. And of course, they save lives. So your immune system's job is to protect you from pathogens that would otherwise invade your body. Rather than risking infection and doing it the dangerous way around of learning how to be protected against a virus, because you don't know how your body's going to react or how you're going to feel with an infection and no protection, a vaccine can sit there and help train your immune system to be able to fight this without making you sick in the process. And for those who are like, oh, well, I still had some side effects from the vaccine. Yes, that's pretty much your immune system getting kicked into gear. It's the vaccine, telling your system, hey, this is how you fight it, like adjust to it, learn it. And that's just your immune system providing a robust response to that vaccine. But again, you're not getting sick in the process. No natural or live virus is in there, so it's the better way to do it. That's why vaccines are preventatives, more so than anything. These last couple of slides are just how vaccines are made. You guys can read these in your spare time about, the different types of vaccines. And how vaccines are made. This is the whole process that we go through for most of these. And then, of course, COVID-19 vaccines. I need to really update this because this is, back looking at November. But talking about our current COVID-19 vaccines, because we have mRNA vaccines, we've got viral vector vaccines. So mRNA being like Pfizer and Moderna. And then viral vector vaccines being like AstraZeneca and Johnson & Johnson. And then, your inactivated vaccines like Sinovac or Sinopharm. So there's a variety of them out there. And then, of course, at the end, showing like how we will deal with variants. Again, I talk about, COVID and vaccines and variants on a daily basis on Twitter. So if you're not following me on there yet, definitely be sure to. I stay up to date on, our latest numbers. I try to get to as many points around the world as I can. And then also, like I said, always up to date on the most recent studies and try to keep everybody up to date on the vaccines that we're working on. And then what you can do to help. So I don't have any flyers out right now, but if you want this, just, send me a note. I can give it to you. This is one thing that I want all of you guys to be able to take away from this since you're over at the convention right now. Just some things to be able to take care of yourself and others around you. Some of you are probably familiar with the 6-2-1 rule. 6 hours of sleep per night, 2 meals per day, at least 1 shower per day. So remember, these are lower limits. They're not intended to be upper limits. So please get more than this. This is like the lowest possible. But this will help keep your immune system strong and functioning and keep you happy and healthy. And again, those around you happy and healthy. And then, of course, helping to stop the spread of respiratory diseases like COVID-19, and other diseases that are going around, whether it's, influenza or RSV. There's a lot of stuff going on right now due to the cold season being around. So remember, wash your hands, wear your mask, stay home if you feel sick. Make sure to cover your coughs or your sneezes. And then, of course, get vaccinated if you can. That is the best and safest and effective way to help us stop the spread and get around this. And if you need me, you can always find me. This is my Twitter account at Sailor Roo Scout. And then if you don't want to ask on Twitter, or if you don't have Twitter, you can always email me at askchise@gmail.com. And just remember that science rules.